Forget everything you think you know about traveling to the moon. Most people picture a rocket pointing its nose at that glowing white orb and firing engines in a straight line. But space is a realm where nothing stands still. Our solar system is screaming through the galaxy at 800,000 km/h, and the moon itself is racing around the Earth at nearly 3,700 km/h. If NASA aimed the Artemis II mission at where the moon is today, by the time the crew arrived, they would find themselves staring into the absolute void of deep space. The moon would be long gone. Instead, the Orion spacecraft is aimed at a ghost, a calculated point in the dark where the moon hasn't arrived yet. It is a high-speed orbital interception, essentially firing a bullet to hit another bullet. The math behind this is so flawless that during critical phases, the spacecraft doesn't even need to burn its engines to correct its course. It is a masterclass in celestial ballistics, aiming for nothingness to hit the bullseye of the future. The journey begins April 3, 2026 at Kennedy Space Center, a mission fueled by ambition and the hard reality of physics. Earth's gravity is a relentless anchor. If Artemis II tried to fly directly toward the moon from the launch pad, it would fail. To break free in a straight line, the rocket would require engines so massive and fuel loads so heavy, they would be economically and physically impossible to build. To solve this, the Space Launch System, SLS rocket, uses a horizontal tip maneuver. After the initial vertical ascent, the rocket tilts. It uses Earth's gravity as a tool, swinging the craft in a circular path. As it builds up terrifying speeds, it begins to loop around the planet in larger and larger circles, climbing higher and higher like a weight on a string. Only after building this massive momentum does the rocket give one final push, the translunar injection, to finally escape Earth's pull and head for the deep. The vehicle making this possible is the SLS, the most powerful rocket ever successfully ignited. Its architecture is built for raw, unadulterated power. The core stage, flanked by two 5-segment solid rocket boosters, generates 8.8 million pounds of thrust at liftoff. This is the muscle required to lift the Orion spacecraft into the arena of the gods. Orion itself is the product of an elite international partnership. While NASA developed the crew module to protect the 4 astronauts, the European Space Agency, ESA, built the European Service Module, ESM. The ESM is the heartbeat of the ship. It provides the propulsion for course corrections, powers the avionics via its 4 X-wing solar arrays, and contains the life support systems. Without this European-built powerhouse, Orion would be a cold, dead shell in the vacuum. Together, they form a vessel capable of sustaining life for a 1.4 million-mile journey through the most hostile environment known to man. The process is a violent series of events. 2 minutes after launch, the solid rocket boosters finish their job and are jettisoned into the Atlantic. Shortly after, the core stage shuts down and falls away. Now, Orion is pushed by the Interim Cryogenic Propulsion Stage, ICPS. After reaching orbit, the ICPS performs the burn that sends Orion toward the moon. But Orion doesn't leave Earth's vicinity immediately. It enters a high Earth orbit, HEO, a massive 24-hour elliptical loop. This is the mission's final checkout phase. Here, the crew tests the life support and manual piloting while they are still close enough for an emergency return. Once every system is confirmed green, the spacecraft transitions to the lunar flyby. It swings behind the moon's far side, reaching 4,600 miles beyond the lunar surface, before the moon's gravity naturally slingshots the craft back toward home. Safety dictates the trajectory of Artemis II. This is a hybrid mission design. By first utilizing the high Earth orbit, NASA ensures the crew isn't committed to the deep void until the ship is proven healthy. The real magic happens during the free return trajectory. Unlike missions that enter a circular lunar orbit, Artemis II uses a slingshot path. This is a passive safety feature. If the main engine were to fail after the lunar flyby, the ship's own momentum and the moon's gravity would act as an invisible tether, pulling Orion back to Earth automatically. It is a trajectory designed for human survival, ensuring that the path to splashdown is always open, regardless of mechanical failures. Survival in deep space depends on a chemistry lesson most people ignored in high school. Every time an astronaut breathes, they produce carbon dioxide, CO2. In the confined space of Orion, carbon dioxide is a silent poison. NASA's solution is the camera system. The air is pushed through a material coated in amines, molecules that act like chemical magnets. These amines grab the carbon dioxide molecules, scrubbing the air clean for the crew. To empty this chemical trash can, the system uses the vacuum of space. By exposing the saturated material to the zero-pressure void outside, the amines are forced to let go of the carbon dioxide. The gas is sucked out into space, and the material is instantly refreshed. It is an autonomous, infinite cycle of purification that turns the vacuum of the great unknown into a janitor for the ship's atmosphere. As Orion approaches Earth at speeds exceeding 25,000 mph, the mission enters its most critical transition. Most people say, Orion returns, but that's not entirely true. The vehicle that traveled 1.4 million miles must now split in two. Just before hitting the upper layers of the atmosphere, the crew module performs a final separation from the European Service Module, ESM. The ESM has been the mission's unsung hero, providing power, propulsion, and air for 10 days. But it lacks a heat shield. As the astronauts in the crew module brace for impact, the service module is jettisoned, falling behind to be consumed by the friction of the atmosphere. It burns up completely, a planned sacrifice that sheds dead weight and ensures the astronauts have the correct ballistic trajectory for re-entry. Now, only the cone-shaped crew module remains. It is the only part of the original SLS stack that actually survives the journey. Facing the 5,000-degree wall, the capsule turns its blunt end, the heat shield, toward the fire. This is the ultimate test of the Avcoat thermal protection system. While the ESM turns to ash, the capsule carries the crew through the plasma blackout, eventually deploying its parachutes for a precision splashdown in the Pacific. During this blackout, the crew is essentially alone in a fireball. Once the atmosphere slows the craft to subsonic speeds, a sequence of parachutes, 2 drogues followed by 3 massive mains, blossoms in the sky. Orion splashes down in the Pacific Ocean, where the U.S. Navy and NASA recovery teams are waiting. The return of the crew marks the successful completion of the most complex human flight path in history. Artemis II is fundamentally different from the Apollo missions or the uncrewed Artemis theme. It prioritizes crew safety through its hybrid trajectory and tests a sustainable, regenerative life support system that doesn't rely on heavy, disposable canisters. Its strategic importance is the foundation for Artemis III and beyond. By validating the SLS, the Orion spacecraft, and the international cooperation with the ESA, this mission proves we have the infrastructure to stay. This is the blueprint for a permanent lunar base and the eventual journey to Mars. We aren't just visiting the moon, we are reclaiming our place as an interplanetary species. The success of Artemis II tells the world that the moon is no longer an unreachable dream, but a reachable destination. The precision of the trajectory, the ingenuity of the oxygen scrubbers, and the sheer power of the SLS have opened the door to the stars. 1.4 million miles later, the journey is over, but the story of our return to the lunar surface has only just begun. We are going back, this time to stay.